So welcome everyone. Welcome to today's session. And in today's session, we are going to discuss last 5 years of IIT JAM PYQs. And we are going to touch the modern physics topic. Modern physics basically include 3 to 4 topics, which are pre-quantum mechanics. You can say number one is black body radiations. Number two is photoelectric effect. Then we have is a Compton scattering. And one very particular topic, which is very important for JAM just or GATE as well, is phase velocity and group velocity. So these are the 4 topics I'm going to touch in this session, and I'm going to discuss all the PYQs which have been asked in last 5 years. So this is not going to be a very detailed class, but at least we will have some basic ideas we will touch about all the topics. So let's start. So let's begin with the black body radiations, and let's see all the questions which have been there in black body radiations. In black body radiations, the very first question which came is this. So the question is that ultraviolet catastrophe in the classical Rayleigh gene theory of a cavity radiation is attributed to the assumption that. So basically they're asking that why does the ultraviolet catastrophe happen? And if you have watched my lectures, we have covered it in detail. What is black body radiation and what is ultraviolet catastrophe. Let me give you a very brief idea about ultraviolet catastrophe and black body radiation. So in black body radiation, what we assume is that atoms are vibrating. So atoms are a harmonic oscillator. So if atoms are vibrating, they will emit some radiations. So that emission of radiations we want to study. So atoms are emitting the radiations of different frequencies. So there are different frequencies possible. Different frequencies are possible. And we find out a very important parameter which is known as spectral energy density. So this is known as energy density. Okay. So let me go to the notes of the black body radiation so that we can make this process little quick to understand this concept. What do we actually try to see in the black body radiation? So in black body radiations, what we are interested in is this graph. And this is a graph between energy density as a function of frequency. Now we will understand this energy density in detail. So energy density is energy per unit volume per unit frequency. Sometimes it is also defined as per unit temperature as well, but that is a different thing. Okay. So let me come to this. So we need this graph. We need this. How does this energy density depend upon frequency? So energy density is very simple concept. So energy density. So first of all, you take a total energy divided by volume. Perfectly fine. Now you are looking at energy per unit volume. So now you are dividing this energy into different frequencies. Okay, how much energy is there for 1 to 5 hertz frequency? How much energy is there for 5 to 10, 10 to 15, 15 to 20, 20 to 25? So how much energy you are keep on giving? So how much energy 1 to 5 frequency have? How much energy 5 to 10 frequency have? How much energy 10 to 15 frequency have? And so on. And if you look into this graph, you should get this kind of graph. So energy should first increase and then should decrease. But ultraviolet catastrophe says that no, energy will just keep on increasing. Okay? Why it is happening? Why we get ultraviolet catastrophe? That is the basic question in that IIT JAM. So in this context, the 2 people came into play. One was Rayleigh and Jeans, and the second was Planck. So Rayleigh and Jean gave the classical model, Planck gave the quantum model. So what was the classical model saying? So classical model basically says energy density depends upon 2 things. Okay? It is a general. It's not just solely for classical. It is a general thing that energy density depend upon 2 things. Number one, density of states, and number 2, average energy. So if someone asks you, okay, okay, how much is the energy between 1 hertz frequency and 5 hertz frequency? How much energy you are giving in this range? Okay. So if the body is emitting total 100 energy, how much energy is being emitted by the frequencies between 1 and 5? So then you will ask 2 things. Okay, how many atoms are oscillating between 1 to 5? How many oscillators are oscillating at the frequency which is between 1 to 5? So let's say there are 100 oscillators which are oscillating. So how many of the oscillators have the frequency between 1 hertz frequency and 5 hertz frequency? That is known as density of states, or you can say number of harmonic oscillators per unit frequency per unit volume. So how many harmonic oscillators are oscillating between this frequency range? And the second thing is, what is the energy of every oscillator? So let's say the energy of every oscillator is 10 joule, and there are 20 oscillators which are oscillating between 1 to 5. It means how much energy is there between 1 to 5? 20 into 10, which is 200 joule of energy is there between 1 to 5. And that is your energy density. So the best way to calculate energy density is to multiply two things. Number one, how number density, how many oscillators are having the frequency between this and this. And number two, what is an average energy of each oscillator? So when we do the calculation of this thing, we come out to be this formula. And if you want detail, you should watch the lecture on black body radiations. We get this formula, which is 8 pi nu square by c cube, which basically tells you how much number of oscillators are there between the two frequencies. So let's say I want to know how many oscillators are between 5 hertz and 5.1 hertz. So I will put my nu here as 5 and I will get the answer. Similarly, if I want to know between 10 and 10.1, I will put the value 10 and I will get the answer. That is okay. That is general. Till now, there is no difference between classical and quantum. Both agree till this point. Both says, okay, theek hai. We agree that atoms are oscillating. Atoms are oscillating at different frequencies. And how many atoms are there in this frequency range? You can find by using this formula. Both of them agrees. Quantum as well as classical. The difference comes now. Classical theory says, what is an average energy of each oscillator? Okay, let's say there are 10 oscillators which are between, or 20 oscillators which are between 1 to 5. Now, what is the average energy of each oscillator? So the classical theory, which is basically based on the equipartition theorem, says that every oscillator has an average energy kT. Every oscillator. Does not matter if this oscillator is between 0 to 5 or 5 to 10 or 10 to 15, 15 to 20. Does not matter what is the frequency of the oscillator. Every oscillator will have the same energy. And that was the problem. Because you see, this thing is, so your energy density is depending upon two things. Number one is N. N is increasing with frequency. So if you keep on increasing frequency, this parameter keeps on increasing. And if you multiply it with KT, KT is independent of frequency. KT does not depend upon frequency. So that is gone. So overall, you will just keep on increasing with frequency, increasing with frequency, increasing with frequency, increasing with frequency. And that will come at ultraviolet catastrophe. Ultraviolet catastrophe means that if you put a very large value of frequency, then energy will also be very large. It means the most of the energy is there in the ultraviolet region. And our entire universe will basically get destroyed. If most of the energy is in ultraviolet region, so the sun will basically giving us is everything in ultraviolet. It will not be giving us most of the energy visible or most of the energy in infrared. So that was ultraviolet catastrophe. And the two factors are there. One is number density and another second is equipartition theory. Number density says that how many oscillators are between these two frequencies, and average energy say what is an average energy of each oscillator. Average energy of each oscillator is basically kBT or KT according to the equipartition. So if we use these two results, we get ultraviolet catastrophe, because then you can just multiply these two. So you will get 8 pi nu square by c cube into KT. So this is your energy density. And you can clearly see that this will just keep on increasing with frequency. So if you just keep on increasing the frequency, energy will also keep on increasing. So it means if you have, let's say between 1 hertz and 10 hertz, you have 10 joule of energy. Then between 100 hertz and 110 hertz, you will have almost 10,000 joule of energy. So energy will just keep on increasing. So it means that any body is emitting most of the energy at high frequencies. Most of the energy which a body is giving most of its energy to the high frequencies. It means the sun should give us maximum energy in the ultraviolet region, which is not true. which is not true. If you look at the graph, graph should first increase and it should decrease, which basically tells us that at the higher frequencies, energy is not that much. At lower frequencies, energy is not that much. Energy is maximum in middle of some higher frequencies and in some lower frequencies. But according to the ultraviolet spectroscopy, this graph will just keep on going like this, which is wrong. Okay. So how was this theory basically fixed? So the theory was fixed by the Planck, and Planck said, okay, wait a minute. Energy is not fixed for every oscillator. Energy depends upon the frequency. So energy will be actually NH nu, H nu. So energy actually depends upon nu. How much energy oscillator will have will depend upon the nu. Okay. So then he calculated the average energy using the statistical mechanics. Then the Planck calculated the average energy. What will be the average energy for every oscillator? So when the average energy was being calculated, so this came out to be your average energy. You don't need to go for derivation. If you want, you can look at the lecture. It has been done very nicely. Now, this average energy formula says ki no. As you go for the higher frequencies, N is increasing, but average energy is decreasing. You can see the exponential decrease in average energy. Because energy density depends upon two things. Number one, how many oscillators are there at that frequency? And second, what is the average energy of those oscillators? So one thing is true, n is okay. N is still 8 pi nu square or by c cube. That is still agreeable. We still agree, okay, n will keep on increasing, but the average energy of oscillators will keep on decreasing. So if you have a ultraviolet frequency, its average energy will be less. And it will be exponentially less. But if you have an infrared, you can say, frequency, its average energy will be more. Okay? So the overall effect is that after a certain time, energy will decrease. And that was able to explain. So what did we change here? We changed the formula for average energy. We changed the concept of average energy. We did not change the concept of number, density of states. Both quantum Planck and both Rayleigh-Jean agrees ki how many atoms should be there in this frequency. That is agreed by both of them. But what is not agreed by both of them is ki every oscillator has the same energy. No, every oscillator has same average energy. That is kinetic theory of gases. On the other hand, every oscillator has average energy which is decreasing with frequency. So that is sort of this graph. First increase, then decrease. Not directly, first increase, then decrease. That is a difference between Planck and the classical theory. So Planck says the average energy every oscillator which has is first increase and then it will decrease. So the maximum energy is not available to the very low frequencies. It is not available to the very high frequencies. Maximum energy is available to the in between somewhere. Okay? So that is an average. That is an average. Okay? So that basically explains the formula. So now let's come to our question and let's try to understand. So why does ultraviolet catastrophe happen? So let's read the statement. The standing waves of all the allowed frequencies in the cavity have the same average energy. Yes, that is the reason. That is the reason. So this is the true answer. So basically why ultraviolet catastrophe happens? It happens because there is an assumption that all the frequencies will have the same average energy, which is not true. Okay? Which should not be true. That is why the ultraviolet catastrophe happens. And option number A is correct in this case. Okay? So please ask me any doubt if you have in this concept. Okay, so then we come to the question for 2023. Okay? So in 2023, what was the question which was being asked? So in 2023, they are asking the spectral energy density versus wavelength curve. So basically, again, so they are plotting the graph of U versus wavelength. You can plot the graph of U versus wavelength or U versus frequency. For a black body, shows a peak at lambda equals to lambda max. So what will happen if you double the temperature? So basically, you have the graph like this. So the peak is coming at this wavelength. So what will happen if you double the temperature? So in this case, the two laws are very useful, which are there. One is the Wayne's displacement law, which we discuss in the lectures. And the second is the Stephen's law. So basically wherever you say the maximum of the energy density comes, that is known as the maximum, lambda maximum. So at this wavelength, energy is maximum. So I told you, no? So energy is not available to a energy is less for less frequencies, energy is less for high frequencies. Energy is more for somewhere in between. So the wavelength or the frequency where the energy is maximum is known as lambda max or nu max. So max is that wavelength which has the most average energy. Lambda max, so let me repeat this. Lambda max is that wavelength which has the most average energy. So basically, everybody emits a radiation which contains most energy. For example, our sun emits most of its energy in visible and infrared. It emits very less ultraviolet, it emits very less X-rays. It emits somewhere in the range. Most of the energy coming from the sun is in the range of, you can say, visible and you can say infrared. So who decides that? Temperature decides. Depending upon the temperature, your body will emit the radiation. So according to the Wien's law, lambda max is inversely proportional to temperature. So if you see and look at the lambda max, it will be inversely proportional to temperature. So if you double the temperature, your lambda max will become half. It means your graph will become something like this. Lambda max became half. So if you double the temperature, so the lower wavelengths or the higher frequencies will become dominating. So if you double the temperature of the sun, so what will sun start doing is that it will start emitting the UV radiations more. It will start emitting the gamma radiations more. Okay? Lower frequencies and higher wavelengths will start getting emitted more if you double the temperature. Okay? So the temperature decides in what range the maximum energy will be emitted. Okay? So Wien's law says that lambda max is inversely proportional to temperature. So if you double the temperature, lambda max will be half. So you see lambda max has been reduced to half its value. So our option number A is true. So the maximum shift to lambda max by 2. Perfect. Maxima has shifted by to half. Then comes, so A is true, B is wrong. Then comes C and D. So area under the curve. So the area under this curve is defined as the intensity. This has been covered in the lecture. So if you find the area under this graph, you will get the total intensity of the light which is being emitted. How much is the total intensity of the light which is being emitted by the body? So that is always equals to sigma into T ki power 4. This is known as Stephen's law. So intensity depends upon sigma, or you can say intensity is basically depending on T ki power 4. Sigma is just a constant. So if you remove the proportionality constant, you get a sigma. In more general terms, intensity is actually depending on area into T ki power 4. Sometimes area parameter is also important. So how much intensity a body will emit will depend upon two things. Number one is what is the total surface area of this body? And number two, what is the temperature of this body? So based on that, the energy will be emitted. So area into T ki power 4. Usually area is useful in some problems. In most of the cases, the temperature is the most important parameter. But we should know this formula. So intensity is directly proportional to T ki power 4. So if you double the temperature, intensity will become 16 times. So the area under the graph, which is basically intensity, will become 16 times. So that is our C option. So C is also correct. So the area under this graph will become 16 times the original area. It is not 8 times, it is 16 times. So it was a multiple select question which has a correct answer A and C. Okay. So any queries in this concept, please? Okay. Now comes the question 2021, third question. So you see in the last 3 years, 3 questions. So every year black body question has been coming up. Now this question is little bit different. And this question is actually a combination of ideal black body and non-ideal black body. So what is happening here? So they are saying that an ideal black body at temperature T emits the energy density U. So you have an ideal black body. It is at temperature T and it is emitting the energy density energy density U. ठीक है. Now corresponding to the value for a material at temperature T by 2 is U by 256. So read that line very carefully. The corresponding value for a material, some other material, is T by 2 is U by 256. What is the emissivity of the material? Okay, that is a question. So now we have the two things. One is the perfect black body, and one is the some sort of material which is not perfectly black body, which is emitting the radiations, but it's not a perfect black body. Okay. So let's talk about the black body first. For black body, we know the formula U is equals to sigma T की power 4. But for some material, the formula will be U into epsilon into sigma T की power 4, where epsilon is the emissivity. The value of emissivity is between 0 to 1. Now, basically, emissivity is a parameter which tells you that how good your body can emit the radiations. For example, not every body emits the radiations. If you heat up the bodies, some bodies like to emit the radiations, but some body do not emit the radiations. For example, if you heat the coal will emit the radiations. But if you heat the plastic will emit the radiations, but more than emitting radiations, plastic will just melt. So the energy will be used in melting rather than emitting radiations. Similarly, for the rubber, if you heat the rubber will first change its shape and then it will think about emitting radiations. But on the other hand, if you heat iron will start emitting radiations immediately. So that is the difference. So perfect black body has emissivity 1. Okay, this is a perfect black body. If you heat, it will not change its shape or it will not do anything else. It will just emit radiations. And the perfect reflectors means basically those bodies which do not emit radiations have the emissivity 0. We always have emissivity between 0 to 1 for all the bodies in this universe. Okay? So what is now given to us is that we have one black body, perfect black body. At temperature T, its U is given by sigma T की power 4. Okay? But for some material, the temperature is actually T by 2 and its energy density is actually U by 256. Okay? So I will use that concept. So U dash is given by epsilon sigma T की power 4, but the temperature of the material is actually T by 2. So I have to do T by 2 की power 4. So this will give me epsilon sigma T की power 4 by 16. And the energy density of this material is given by energy density of black body divided by 256. It is given. The energy density of the material is energy density of black body divided by 256. Energy density of the black body is U. Energy density of the material is U by 256. So basically this is U by 256. Okay. So what is U? U is sigma T4. So basically epsilon will, so this and this will cancel. So epsilon will come out to be 1 by 16. 1 by 16 is almost 0.063. Okay. So a very good comparison was given here. So for black body, U was sigma T4. And for the material, it was epsilon sigma T by 2 की power 4. Okay. This thing is actually 256 this thing divided by 256, because if this is U, then this is actually U by 256. Okay. So I will make this equals to U by 2. So for the material, energy density is 256 times less. And the formula for energy density for any random material is not only sigma T4, but epsilon also has to be multiplied, because epsilon decides how good your body can emit radiations. If you have a perfect black body, then epsilon is 1. But if you don't have a perfect black body, then epsilon will take some value between 0 to 1. In our case, it is taking a value 0.063. Okay? So if you heat the body, only 6.3% of light will be in the form of radiations. Rest, all the energy will be used in some other things. That is the meaning of emissivity. Clear? So I hope this is clear. And yeah, please, any doubt in this one, let me know. Yeah, is it clear or any queries? Then comes the last problem from black body, which was asked in 2020. Okay? So So this is question number 4 and it was asked in 2020. So this was a year when I gave the JAM exam. So this question came when I was giving the exam, and very simple question. Consider the two spherical perfect black bodies with radius R1 and R2. So you have two spheres, both are perfect black bodies. One has a radius R1, another has a radius R2. One is at temperature 1000 Kelvin, another is at temperature 2000 Kelvin. They both emit the radiations of power 1 kilowatt. Means the power or the intensity of both of them is same. Okay. What is the ratio of their radii? So I will just make intensity of both of them same. And then intensity formula is, intensity depends upon area and temperature to power 4. So sigma into area 1 into temperature 1, 4. Sigma into area 2 into temperature 2, 4. Sigma symbol cancels. You know area depends upon pi r square, right? 4 pi r square. So it depends upon radius square. So here you will see r1 square and t1 ki power 4. And here you will see r2 square and t2 to power 4. So r1 by r2 square is actually equals to t2 by t1 ki power 4. The second body has temperature 2000, first body has temperature 1000, 2 by 2000 by 1000 is 2, 2 ki power 4 is 16. So r1 square by r2 square is 16. So r1 by r2 will be 4. So the answer to this problem will be 4. So in this concept, you have to use the formula. Intensity is not only depending on temperature 4, but it also depends on area, and then it also depends on T ki power 4. So here the concept of area has to be used. In the previous question, we said that, okay, if it is not perfect black body, then you also have to multiply epsilon as well, which is the emissivity. Okay. So we saw the formulas, and we also saw what kind of variations you might have to do in the formulas. Okay. So black body is a very important topic. I would really recommend you to watch my lectures on black body. This has been covering in IIT JAM exam in almost all the years. So yes, any doubt in this one? Otherwise, I will move to the next topic for today. So the next topic, which is very important for us, is group wave and phase wave. Basically, we need group velocity and phase velocity. So whenever the wave is traveling, there are two parameters we are very interested in. How fast the wave phase is moving. Moving of the phase basically means, let's say you are looking at the maxima of the wave. So how fast the maxima is going forward. And the group velocity basically means how fast the energy is being traveled from one place to another. Sometimes for example, in standing waves, the maxima minimas are moving, but the energy does not transmit from one place to another. So not every time energy is transmitting at the same rate at which the phase is moving. So phase is basically tells you that how any particular phase, let's say maxima or a minima, how fast maxima or minima is moving forward. And the group velocity basically means how fast your energy of the wave is traveling from one place to another. There are few formulas which are very important for us, and though they are noted like this. Phase velocity is given by, so first of all, you should know what is dispersion relation. Dispersion relation is a relation between omega and k. Omega is known as a wave frequency, which is 2 pi nu, or angular frequency or wave frequency, and k is known as the wave vector, which is 2 pi by lambda. So basically, what is the relation between nu and lambda, frequency and lambda, or what is the relation between omega and k? So dispersion relation basically tells you what is the relation between frequency and wavelength, right? That is very important. So if you change the wavelength, how will your frequency will change? And that will decide all kind of speeds. Group velocity or phase velocity, all the velocities are decided by this dispersion relation. Now, dispersion relation can change with the material. So if you are in one particular material, the relation between omega and k will be something else. If you are in second kind of material, the relation between omega and k will be something else. So it's basically a material's property. Dispersion relation is decided by the material property. If frequency and wavelength are inversely proportional, then it is okay. Then you can say, okay, this is a normal medium, vacuum, or so on. But in most of the cases, omega and k have a very strange relation between them. And that relation is known as a dispersion relation. And this relation is deciding by the properties of the material. Okay? So in solid state physics, that is why you see the dispersion relation a lot. You will see many times, you will see omega and k relation. So the formula is, once you are known, the dispersion relation are always given in the problem. Until unless you are in CSI or NET in solid state physics, in that case they can ask you to find dispersion relation, but that will become a very different question. In most of the questions, if it is from group velocity and wave velocity, dispersion relation is given to you. Once the dispersion relation is given, the phase velocity is given by omega divided by k. So if you do omega divided by k, you get phase velocity. But if you do d omega by dk, you get a group velocity. Means you have, if you differentiate omega with respect to k, you get a group velocity. But if you do omega by k, you get a phase velocity. Okay? Sometimes these relations are given in terms of refractive index. Sometimes for any medium, dispersion relation is not given. They do not tell you that how omega is changing with k. Instead, what they are telling you is how the refractive index of the material is changing with wavelength. So, for example, in few days ago, we studied the wave plates. So for different wavelengths, the refractive index was different. Similar is the case here. So how does your refractive index is changing with the wavelength? So if you have a red light will think that, okay, refractive index is 1. Green light will think refractive index is 1.7. Yellow light will think the refractive index is 1.5. So that is known as the dispersive nature. Because if everyone thinks that wave, for example, vacuum, for every wavelength, refractive index is 1. So that is why you see white light as white light. You don't see the colors being split up. But once you pass it through the prism is such a body for which refractive index depends upon wavelength. It's a dispersive medium. Dispersive medium basically means that its refractive index depends upon the wavelength. So then when the light passes through it, every color sees the different refractive index and every person bends by a different amount. That is why you see all the colors getting split up. So in dispersive medium, colors disperse, they split up because every wavelength is looking at the refractive index differently. For every wavelength, refractive index is different. Okay? So sometimes they give us the relation between n as a function of wavelength. How the refractive index depends upon wavelength. N is the refractive index and lambda is a wavelength. In that case, the formula for phase velocity is c by n. And the formula for group velocity is c by n minus lambda curly n by curly lambda. So these two are the very important formulas. So once we know this, then we can come to the problems which have been asked so far in IIT JAM in last 5 years. So this is my question number 1. Let's see what is given to us. So they're saying that suppose there is a dispersive medium. Okay, we have a dispersive medium whose refractive index depends upon the wavelength. Yes, it will obviously happen. And the formula is given to you. How n is depending on lambda is given to you. They are saying that the value of lambda at which group velocity and phase velocity are equal. So for what value of lambda, group velocity and phase velocity will be same. Okay, are same. So let's see. So phase velocity is given by c by n, as we saw, and group velocity is given by c by n minus lambda curly n by curly lambda. So n is n and lambda is lambda. Now we have to do curly n by curly lambda. So I just have to differentiate this thing. So if I do differentiate this thing, I will get this. Minus 2a by lambda cube plus 4b by lambda 4. This is something I will get. Okay. So now I can just take negative 2 common and I can multiply lambda inside. So I multiply lambda inside and I take negative 2 common. So I will get this relation. So you can see negative 2 if you take common, here I will get is plus and here I will get is minus 2. You can see. And if I multiply lambda inside, so if I multiply lambda inside, so this will be lambda square and this will be lambda cube. So it will be little different. So let me fix this. So this will be lambda 5, right? This will be lambda 5. So if I multiply lambda inside, so this will become lambda square and this will become lambda 4. Now it is okay. Now it is okay. Yes, this is a correct maths. Perfect. So now I want my group velocity and phase velocity to be equal. So if I make them equal, so this is my phase velocity and this is my group velocity. So this is lambda square and this is lambda 4. You can clearly see that these two things will be equal if this thing goes to 0. If I make this thing 0, then both of them will become equal. So in order to make this thing 0, I can say that a by lambda square should be equals to 2b by lambda 4. I will make them equal, so this thing will be 0, and then both sides will become equal. So if that is the case, then my lambda square will come out to be 2b by a, and then my lambda will come out to be under root of 2b by a. Okay? So that is the case. So this is what you have. Okay? That is why your option number A is going to be correct in this case. Okay? So that was the case, and it is a good question actually. You should know the formula. How does the group velocity and phase velocity can be written if dispersion relation is not given, but the wavelength is given. Oh, sorry, refractive index is given. So that was the question. Any doubt in this one, this problem as such? Yeah, please let me know. So the phase velocity Vp of the transverse wave in one dimensional case. So in this case, they are giving you the, indirectly they have given you the dispersion relation. Not directly, but indirectly. So basically what they have given you is phase velocity, and what they are asking you is group velocity. So phase velocity is what? Omega by k, and it is given to you as c sine k d by 2 divided by k d by 2. So I can cancel this k and k on both sides. So omega will be this. So omega is 2c by d into sine k d by 2. And then all I have to do is group velocity is d omega by dk. So I just need to differentiate this. So I will get 2c by d, and if I differentiate this, I will get d by 2, and then differentiation of sine is cos. D by 2 can cancel, and the final result that you get is c into cos k d by 2, which is your option number B. So a very simple question in which the direct phase velocity was given. You can easily find out omega versus k, and then you differentiate it out. And once you differentiate, you get the group velocity. So very simple question. There was nothing in this, and this is one of the simplest question. This was asked in 2023 in IIT JAM. Clear? Now let's see the question number 2022 question. In this also, the omega versus k relation is given. Omega is under root k square plus a square, and they are asking that you draw the graph of group velocity as a function of k. So what is the relation between group velocity versus k? So first thing is that we have to find group velocity. So the group velocity is given by d omega by dk. So you differentiate this thing. If you differentiate this thing, you will get this, and if you cancel, you basically get this. You can easily differentiate. So now you have to graph this. How will you graph this? So basically, let's take a simple case that y is equals to x by x square plus 1. So basically, I need to know the graph of this function. K by a, basically, we need to know the dependence. So that is why take a as 1. Because all I am interested in is the dependence. How my graph is changing with k. So all I need to know is the graph of x by x square plus 1. So how to plot the graphs? If you watch my graph plotting lecture, then you know the very first thing. First, we try to see what will happen if x is 0. So if x is 0, y will be 0. So graph should start from 0. So every graph is starting from 0. So it does not give me any additional information. But what will happen if x is infinity? If you directly put infinity, you get infinity by infinity, which does not make any sense. So first thing I should do is I should take the x square common from here. If I take x square common, if it comes outside the under root, it will become x. So then x and x cancel out, and here inside I have is 1 plus 1 by x square. Now put infinity. If you put infinity, this thing will go to 0, and this has already cancelled out. So basically this thing will go to 0, and final answer you will get is 1. And 1 is a constant. So it means when you go to infinity, your value should be constant. At x infinity, your y should be constant. And B graph only satisfies that. B graph satisfies that. Because if you see A, at infinity, this graph will go to infinity. In this case, at infinity, your graph is going to infinity. At this, you see graph is going to 0. At infinity, your graph is going to 0. But in this case, you can see your graph is going to constant when you go to infinity. So which graph is true? Graph number B. So in this case, all you have to do is differentiate, get a relation, and then plot the graph. In order to plot the graph, I do two things. One, I try to find out the value when x is 0, and then I try to find out the value when x is infinity. x equals to 0 does not give me anything as such, but x equals to infinity tells me the reality that once you go to infinity, your value should become constant. Okay? Yeah, any query in this question? Yeah, then I will go for the next topic. So these were the three problems that were asked in last 5 years in IIT JAM from group velocity and phase velocity. So the next concept that we want to understand is Compton scattering, and the lecture are available for Compton scattering as well. So Compton scattering basically is an inelastic scattering. So it is an inelastic scattering. So what happens is that you have an electron inside an atom. So you have an atom and then you have an electron inside an atom. So this is a free electron. Free electron means a valence electron. So X-rays comes. So let's say the X-ray of wavelength lambda is coming, and then the X-ray will scatter. But what happens is that scattered X-ray do not have the same wavelength as the incident wavelength. So the X-ray which was, let's say X-ray was coming at 2 angstrom, but when it will scatter, it will become 2.1 angstrom. Okay. So lambda dash is always greater than lambda. Then it is known as Compton scattering. So Compton scattering is an inelastic collision between photon and the electron. So the photon which is coming scatters elastically with this electron. This experiment cannot be explained on the nature of waves. So if you try to explain with the wave, then this lambda should be equal to lambda dash, and that is known as the Rayleigh scattering. If you take radiations as the waves, then basically what happens is whatever is the incident radiation will be the scattered radiations, and that is known as Rayleigh scattering. But if you take light or an X-ray as a photon, then photon comes, it collides with electron and then scatters. And this is an inelastic collision. So the energy will be different. Energy will be lost. So if you lose the energy, the wavelength will also change. So the wavelength of the scattered photon will be different than the wavelength of the incident photon. This is an effect of the, you can say is effect of the Compton scattering. Okay? If you want all the details, you should watch the lecture, but this was a summary of it. Now, the formula is very simple. What is the change in wavelength? Because you see, incoming wavelength was lambda, outgoing wavelength was lambda dash. So what is lambda dash minus lambda? What is the change in wavelength? So change in wavelength is given by h by MEC. ME means mass of electron. C is the speed of light. 1 minus cos theta. Theta is an angle at which the scattering happened. So at what angle the photon came? Photon came at 0 degree, 90 degree. At what angle the photon came? Or you can say at what angle the photon went. Photon went basically. Are you looking at the 0 degree, 30 degree, 60 degree? At what angle you are looking at the scattering? Okay. A very interesting fact is that the change in wavelength does not depend upon lambda. So if you are using X-ray, the change in wavelength will be same. If you using UV, the change in wavelength will be same. If you are using gamma, the change in wavelength will be same. So it does not depend upon which wavelength you are using. In all the cases, the change in wavelength is going to be same. So delta lambda does not depend upon lambda. So first two options are delta lambda by lambda and delta lambda by lambda. They are not asking about delta lambda. They are asking about delta lambda by lambda. So delta lambda does not depend upon lambda, but delta lambda by lambda is inversely proportional to lambda. Because you can clearly see delta lambda by lambda, it is not depending on lambda, but this is. So this thing is inversely proportional to lambda. Very clear. So if you increase this lambda will decrease. So both have the inverse relation. So that is why option number A is wrong, but option number B is correct. So delta lambda is independent of lambda, but delta lambda by lambda is not independent of lambda. It is inversely proportional to lambda. So that is why option B is correct and option A is wrong. Okay. Then comes the C option. There is no change in the photon's wavelength for all the angles of deflection of the photon. No. Photons wavelength do change. That is the Compton scattering. Compton scattering clearly says that if your photon is coming, then photon's wavelength will change if it scatters. Okay. And the last option is that delta lambda by lambda increase with the angle of deflection. So delta lambda by lambda depends upon theta, which do make sense because if you increase the theta, cos theta decreases, because you know theta 0 पे cos theta is 1, but theta 90 पे cos theta is 0. So if you increase the theta, cos theta decrease. Okay? So if cos theta decrease, 1 minus cos theta will increase, because now you are subtracting a small number from the 1. So if you subtract small number from 1, overall number will increase. So 1 minus cos theta is increasing. If 1 minus cos theta is increasing, then delta lambda by lambda is also increasing. Okay? So delta lambda by lambda actually increases with theta. So D option is also correct. So your B and D both are right, and A and C are wrong. So B and D are the correct answer for this option. So that was your question from the Compton scattering. Yeah, any query in this one? One more question is there in Compton scattering. Yeah, this question was asked in 2022. The second question was asked in 2021. This was also from the Compton scattering. This was much easier question. So what they're asking is that in the Compton scattering experiment, the wavelength is given. So X-rays which are coming has a wavelength which is given to you. Compton wavelength is this. So what is Compton wavelength? So you saw the formula delta lambda equals to h by MEC 1 minus cos theta. So this thing is known as Compton wavelength. In simple words, you can write this as lambda c. So this is Compton wavelength. So then they are asking, okay, so lambda c value is given, it is 0.024. It is a fixed value, it does not change. You can remember this value. When I gave the exam, I remembered this value. The value of the longest wavelength possible for the scatter. So what is the maximum possible wavelength? As I said, that wavelength change. So what is the maximum possible wavelength? So then delta lambda is equals to lambda c into 1 minus cos theta. If I want this to be maximum, I want cos theta to be minimum. So then cos theta minimum is -1. So this thing, entire thing becomes 2. So my delta lambda is equals to 2 lambda c. 2 lambda c basically means 0.048. And delta lambda can be written as lambda dash minus lambda. So lambda dash minus lambda is equals to 0.048. And then lambda dash remains on one side. Lambda you can take on other side. So you get lambda plus 0.048. What is the value of lambda? The value of lambda is 0.5. So 0.5 plus 0.048 gives you 0.548. So this is the maximum wavelength which is possible, and 0.548 is the exact answer for this problem. Okay? So 0.548 was the answer. So delta lambda we calculate, maximum delta lambda, which will be 2 times lambda c. So this was your question number 2 of the Compton scatter. Okay? So the last topic that we want to discuss is photoelectric effect. Photoelectric effect comes out to be the least important topic, and no question has been asked in last 4 years. The last question from photoelectric was 5 years ago in 2020. Okay? And that question was also not very difficult. If you have watched my lecture, you can easily straightforward do this question. If it is not coming from last 4 years, it makes it important. Means it is very possible that next year this question will be there, because now they have asked so many questions from black body. They have asked so many questions from you can say phase wave and group wave. Now they might ask the question from photoelectric. So we haven't seen this question from a long ago. So what is the question? And the question is that in photoelectric effect, what is photoelectric effect basically? So the incident radiations are coming. So photon comes, it hits, and the electron comes out. So there is a metal plate. So when a photon comes and hits the metal plate, electron comes out. And this is a valence electron. So valence electron comes out. So a monochromatic light, obviously, so one fixed wavelength is there, is used with the energy greater than the work function. Work function is the energy which you require to remove the electron. So let's say you need 2 electron volt to remove the electron. The photon which is coming has a more energy than 2. So it will have maybe 3 electron volt energy. So the photon is coming with 3 electron volt. The work function is 2. Work function basically means how much energy you need to remove the electron. So you need 2 electron volt. So out of 3, 2 is used to remove the electron. So when the electron will come out with 1 electron volt energy. Okay? So that is a case. So now what is happened? If the power of the light source is doubled, so light source you are using, power doubled. Power basically means intensity. So power doubled basically means intensity doubled. Intensity doubled means the number of photons which are coming is doubled. So let's say energy will still remain same. So the photons which are coming still have the 3 electron volt energy, but let's say first 10 photons were coming, now 20 photons will come. So the number of photoelectrons which are emitting will also be doubled. So initially if the 10 photoelectrons were emitted, now the 20 photoelectrons will be emitted. But all of them are still emitted by 1 electron volt because energies have not changed. Number of electrons have changed. Okay, how many number of electrons are coming is now doubled. So number of photoelectrons which are being emitted, electrons which are emitted is also doubled. The energy of the incoming radiation is same. Energy of the emitted electron is also same. So the stopping potential will also be the same. So stopping potential is the energy which is required to stop the electrons. Since the electrons are still emitted with the same energy, the stopping potential will remain same. It does not matter if the 10 electrons are emitted or 20. The energy you require to stop 1 electron will remain same because electrons are still being emitted with 1 electron volt energy. So the option number B is correct. All other are wrong because you can clearly see the number of emitted photons, electrons remain same. No, this is increased. The number of emitted photoelectron decreased. No, it is increased. The stopping potential doubled. No, stopping potential remains same. Electrons are doubled, but they are still emitted with the how much is the with what energy they are coming out. Okay. It does not depend upon the battery source. It depends upon the source of the light. What is the frequency of the light which is being emitted? If the light is basically red light or green light, so it depends upon the frequency. If you have more energy coming or if you have less energy coming, it does not depend upon intensity. Intensity means how many photons are going. So by changing that, the energy of the photon does not change. So that is why option number B comes out to be correct. So this was your last question for today. I will stop here. Any doubt you have in today's class, please let me know, right?